Devastating hurricanes, very powerful typhoons, high pressure, and some amazing September stats all feature in this week's Met Office Deep Dive. Plus, we have two special guests. So yes, lots to talk about. Let's get straight into it. My name's Alex Deakin. I'm a weather presenter here at Met Office HQ, and you are watching the Met Office Deep Dive exclusively on YouTube, just for the Met heads. 25 minutes of pure meteorology. If you like it, do give us the heart button, and also make sure you hit subscribe and share the love. Let any other Met heads know that we are here and we do this every Tuesday. Also, really love reading your comments, so if you've got anything to say about this or about anything we do, any questions about weather or climate, then do please pop them in the chat as well. Let's start with a satellite image again, showing swirls out in the Atlantic as it often does, but a couple of things to highlight here. Let's just rewind the fun. Out here, notice the eye in that storm. That is tropical system Isaac. Now, if we run through the next couple of days, you can see that eye kind of fizzles out. No longer a tropical system, but still out in the Atlantic, still generating quite a lot of cloud and outbreaks of rain here. Not really going to impact the UK directly. It's going to be subsumed by other weather systems out in the Atlantic. But a weather system has definitely affected the UK over recent times. The swirl of cloud that came marching in and has been bending around and generating a lot of heavy rain across the UK over recent days. Let's put the radar on and we can see just how over the past 24 hours this arm of rain has bent its way around northern England, down into parts of East Anglia and the southeast, and then it's regenerated itself through the day today. So you can see there the swirl, you can feel the winds coming in from the North Sea. If you're on the North Sea coast today, it must feel pretty grim. I know it's October, but it probably feels more like January. That brisk wind, temperatures really struggling in the teens, coupled with all this wet weather that has caused further flooding over recent days. And I'll show you the September stats in a moment, because we have seen incredible amounts of rainfall across England and Wales. It's not been the same for Scotland and Northern Ireland. But yeah, large amounts of rain coming in here, all courtesy of this area of low pressure and all courtesy of where the jet stream is. The jet is not particularly powerful, that's it here. But the jet stream is south shifted, as it has been for much of September, as it seems to have been for much of this year actually. So a south shifted jet generates more low pressure systems across the more southern parts of the UK, and that is what we've seen. That is why we've got this low pressure tucked in here, still bringing outbreaks of rain. But lo and behold, it is starting to pull away. And what is this? You can see on the horizon a large area of high pressure, and that is actually toppling in. So although we've got these lows out in the Atlantic, this one actually the remnants of Isaac, the jet is so weak and it's kind of dipping to the south. It's not pushing these along. So what we are seeing now is the area of high pressure to the north is slowly but surely building in across the UK. So that is going to generate high pressure, is where the air is sinking through the atmosphere, so it's going to mean a lot more dry weather. Yes, it is still raining across the southeast at time of recording, and there'll still be some showers tomorrow, but generally speaking, this high pressure system moving in is going to keep things fine and dry as we go through Wednesday, Thursday and Friday. High pressure, say sinking air. Notice, however, if we just pull it back a little bit, still the isobar is quite tightly packed together. So if we put the surface winds on, still quite a brisk breeze coming in here. So it will still be pretty chilly on those North Sea coasts tomorrow. And also, as we see some funneling in through here, we are going to see some showers tomorrow across the southeast. So today's rainfall is easing off. Fast forward to 24 hours. There are those winds just generating some showers down across East Anglia and the southeast. So it's not completely dry tomorrow. There will still be these showers feeding in, still quite a bit of cloud and still quite chilly on these North Sea coasts. That's today. Tomorrow, well, we might, with a bit of sunshine, squeak up into the mid-teens, but add on that wind and it will feel pretty chilly tomorrow again along these North Sea coasts. So it is still going to be cool tomorrow, but the high pressure then moves in and really settles things down by the time we get to Thursday, sitting over us. The remnants of Isaac in here, and we can put the temperature profile in. You can see some tropical air still left in with that, but it doesn't really affect the UK. What happens is it gets I try to say subsumed, and I started to say consumed. Consumed, subsumed by this weather system moving in here. Let's show that happening. So yeah, this low pressure will eventually bring some cloud and rain and wind in from the west by the time we get to Friday night and into Saturday. But ahead of that, the high pressure will bring a lot of fine weather on Friday and Thursday, albeit with some chilly mornings, getting to that time of year where the mornings will be quite chilly, quite fresh, and the cold air in place before we see wet and windy weather coming in from the Atlantic, as this area of low pressure, which I say has consumed some other tropical systems, all kind of melanges together into one, bringing some wet weather in from the west. So that is the weather patterns for the rest of this week. We are going to see that high pressure dominating, bringing a chill, particularly to the east coast, but a lot of dry and fine weather. Could be some morning mist and fog. Temperatures dropping away this time of year now. The nights are longer than the days. Obviously, we could see some morning fog, particularly on Friday morning. So that might be a feature for your morning commute. But generally, we'll see a lot of fine weather through Thursday and Friday, thankfully, across the south, where it has been exceptionally wet. Let me show you how wet, because we can look at the September statistics now. Yeah, you don't need me to tell you it's been wet, but these are some of the stats, and this is quite a stark map showing just how wet it's been across a large chunk of England and Wales, well above the average, twice the rainfall and then some. 10 counties have recorded their wettest September on record, and records going back to 1836. And some counties, Bedfordshire in particular, recording its wettest of any calendar month on record. So not just September, for any month. But notice the huge disparity, the huge difference. For parts of Northern Ireland and a good part of Scotland, it was drier than average. Quite a bit dry. In fact, generally across Scotland as a whole, only around 2/3 of the September rain has fallen. So yeah, compare and contrast, quite a difference. And that is also shown in the sunshine statistics. The Western Isles of Scotland, Shetland, all both recording 30% more sunshine than average through September. Much of Western Scotland significantly sunnier than average. Also the southwest of Scotland and the far west of Northern Ireland. And it's in the south, across much of England and Wales, where obviously it's been wet. It's also been a duller than average month. And that all ties in with that south shifted jet. Low pressure systems coming in here and easterly winds generated here, which bring the sunnier skies to the western side of Scotland. And that's also why, with an easterly wind, we've seen temperatures below average across eastern Scotland, whereas actually for much of the UK, this is the mean temperature, so average over the whole day. So although days generally across England and Wales have been slightly cooler than average, because the nights have been a little warmer than average, you kind of average it out. So the mean temperature is pretty close to average throughout, but you can highlight there with the easterly winds more prevalent across eastern Scotland. Temperatures here have been slightly below average. One more chart I want to show you, just because I like the pretty colours. This is showing the number of lightning strikes that we've seen, and you can see that real bulge there across parts of the Midlands, especially down into southern England, where we've had a couple of low pressure systems just generating thunderstorms across those southern areas. So huge numbers of lightning strikes there, up to 200 in some locations, averaged over 5 kilometres. So lots to talk about in the September stats. One final graph to show you here. This is the way the rainfall tracked through the month. So the accumulated rainfall, you can see right from the start we were above average, but actually then a drier spell around the middle of the month meant we were slightly below average for rainfall before a big jump the last week or so of September, significantly above average in terms of rainfall. Slow moving weather systems responsible for that. So an awful lot to talk about in the September stats. You can find out more by visiting the Met Office website and reading our press release, which has much more details about all of the stats for what has been a truly remarkable month of September. Another remarkable thing that we need to talk about in this week's deep dive is Hurricane Helene. That brought devastation to parts of the United States, as we've been through the course of the weekend. A huge cleanup operation is ongoing, and earlier today I was able to catch up with our tropical prediction scientist Julian Hemming, who knows an awful lot about hurricanes and typhoons. Julian, thank you so much for joining us here on this week's Deep Dive. Such a big storm fizzling out now, but talk us through what happened with Hurricane Helene.
Well, what you're actually seeing here is the landfall of Hurricane Helene, so it's a really close-up view here. This picture is actually what we call infrared satellite imagery, showing the cloud top temperature, very cold tops to the cloud, so it meant it was very strong. It was Category 4 at landfall. If you can make out the coastline here, it was coming ashore what we call the Big Bend of Florida, which is the part which bends round and faces into the Gulf of Mexico.
So the red here is actually cold. These are the cloud
what you
tops.
want for very strong hurricanes, you want a lot of warmth and moisture from beneath, but you want it very cold at the top, which allows the strong clouds to develop and rush up, and then the air outflow at the top, and so you get this big kind of circulation which drives a very strong hurricane.
So this was actually at landfall. I think we've got a picture just before it made landfall, but this is kind of a bigger picture. So now you can see Florida a bit more clearly here. There's the eye of the storm. So still out in the Gulf of Mexico at this stage, but quite a impressive cloud head.
Yes, this tells us a lot actually about why we saw such big impacts from Hurricane Helene. Because first of all, it developed down in this area, just off the screen here, in the Western Caribbean Sea, from what we call a Central American gyre, which is a large, broad area of low pressure, which develops in that region. A bit kind of messy to start with, but then gradually the strong storm clouds start to develop, and it forms into this hurricane. And it's larger in terms of its footprint than an average hurricane, as we can see from this.
So that's bigger than usual.
That's bigger than usual. We've had other ones which have hit this area. I can think of some examples in the past, like Hurricane Charlie 2004, which hit along this coast, a tiny little hurricane here. But this is very big in terms of its kind of footprint. And one thing that's really noticeable is this strong stretch of cloud up to the north. And it was connecting to another weather system, and this meant that there was a lot of rainfall pushing inland over southeast USA even before the hurricane made landfall. And then also Helene was moving very fast, so it moved ashore very quickly, so it pushed the rainfall associated with the hurricane itself inland very, very quickly as well.
How fast were we talking in terms of?
It was moving at about 20 to 25 miles an hour, which is a lot greater than an average hurricane, which might move at 10 to 15 miles an hour.
Right.
I think at some point it might have been even faster than that. But then once it got inland, it slowed down and sat over this part of southeast USA, just at the southern end of the Appalachian Mountains. So what happened there was you had all this rainfall being pushed inland, and then sitting over the southern part of those mountains, and then the rain was rushing down the rivers, and that's what caused the catastrophic flooding. And
it picked up a lot of moisture, obviously, from the Gulf of Mexico, as these storms always do. The Gulf of Mexico is slightly, I mean, it's a warm body of water anyway at this time of year, isn't it? But it was slightly warmer than average as well.
I mean, one thing that's been spoken about a lot in the last year or so, actually, is how warm the whole Atlantic, Caribbean and Gulf of Mexico are compared to normal. And that has persisted right through the season. Now, we haven't seen maybe the number of hurricanes we might have expected because of that, because of other factors which were inhibiting them. But with this one, once the atmospheric factors are right, then the sea temperatures are very warm to fuel it.
Let's take a look a little bit about the history then, because you talked about where it formed and how it formed, and this is kind of where it's been, isn't it? This is the graphic of how it started and how it intensified.
Yes, that's right. It started down here in the Western Caribbean, and the little coloured area here is the zone which was experiencing tropical storm force winds. So you can see how that pushed right across Florida, up through Georgia, up through the Carolinas. Because it moved so fast, actually the strong winds moved a lot further inshore than normally happens, because normally the winds die down fairly quickly once a hurricane makes landfall. But the strong winds did move a lot further inland than normal. So there was wind impacts as well as...
and what was the strongest gusts? 99 miles an hour, I think.
The strongest that were observed, yes, were around that figure. At landfall, the estimation of the sustained winds of the storm were actually around about 140 miles an hour. It's rare to actually observe those winds, but that's what was estimated from the techniques we used to analyse the satellite
so
imagery.
It was a Category 4, that made it a Category 4 storm. And it intensified pretty rapidly as it approached as well. It was a Category 1, what, a day before, and it intensified really rapidly.
And again, that's maybe due to the fact that it was moving over some very warm waters. Not only warm waters, but a kind of an area where there's very deep warm water in the Gulf of Mexico. We do get these form occasionally, and there was an area of very deep warm water, which meant that as it moved over that zone, it had a lot of depth of energy, if you like, to draw into the hurricane. The sea surface temperature didn't drop very quickly as the hurricane moved over it.
Okay, it's incredible. All these facets coming together. Not surprising to see that this had such devastating effects. It was a big storm, it was a powerful storm, the sea surface temperatures were above average, and moving really rapidly helped to increase the storm surge, I imagine. We can have a look at the storm surge map here, because people often don't realise that actually with hurricanes, storm surge is one of the biggest killers, which is where the sea levels are actually pushed up by the storm due to the fact that it's low pressure, but also just the geography of it pushing that water means that water levels rise.
That's right. There's kind of multifacets, if you like, to the impacts of a hurricane. And this was actually a forecast of the storm surge just before it hit, but it was fairly much in line with what was experienced. And with the track of the storm heading up into the kind of area of the Big Bend here, you can see the purple areas are showing the highest storm surge, which are marked here as 15 to 20 feet. And I think there's particularly an area around here, Cedar Key, saw some incredibly high storm surge and some real severe damage from that. And what we do get with the hurricanes is that the storm surge tends to be all on the, for Northern Hemisphere hurricanes, on the right-hand side. So the track of the storm was up here, and all the strongest storm surge was this side. In fact, if you went just a little bit to the other side of the hurricane, there was virtually no storm surge at all.
You can see it because it made landfall here, didn't it? And all of that area had
primarily because the winds are circulating
around
that way,
so
and
it's
so
pushing
they're
it
pushing
that way.
all the water onshore that way.
15 feet, that's what, 5 metres. So that's just raising the water level by 5 metres above where it would be normally. So just imagine that. It's just no wonder there's so much inundation around that. So that was kind of the first impact. We talked about the winds a little bit, over 100 mile an hour winds sustained, and the rainfall, which was just incredible, the amount of rainfall. And this, again, this is a forecast, but just showing the areas that were affected.
This is actually the observed amounts over a 3-day period.
Right.
And I mean, just looking at the colours, you can see where the heaviest rainfall was. In fact, it was a long way inland, right over the western parts of North Carolina here. And if you can make out some of these figures, the highest value was marked
just off the screen there. It was 30
inches, which is 750 millimetres. That was a kind of extreme, but generally, right across this area, there was a lot of places with 10 to 20 inches of rain. That's 250 to 500 millimetres of rain.
For comparison, parts of Essex gets 500 millimetres a year. So this is incredible amounts of rainfall.
And the other crucial thing is where it fell, because this part here, where we had the highest rainfall totals, is right at the southern end of the Appalachian Mountains. And so all that water was then cascading down the mountains into the rivers below, and that's what's causing the really devastating flooding that we saw.
That we've seen. It's a combination of being a powerful storm and, I guess, the speed that it was moving, so it had more momentum that helped to take it further inland, as well as the sheer size of it.
That enabled it to get so far inland after landfall.
But then it kind of ground to a halt.
It did, yes.
And that was to do with what's going on.
It was kind of blocked by a high-pressure system further north. It blocked it from moving further north. So it gradually wound down, but there was still lots of rain to come as it did so.
A combination of factors just created this incredible storm. And, obviously, situations very much ongoing in the United States. The storm itself has now eased, isn't it? Just a lump of cloud now, really. But absolutely phenomenal amounts of rainfall, devastating winds, and that storm surge just combining to make Helene something we won't forget in a hurry. That's not the only storm that we're talking about today, however, because there is another one potentially dropping similar amounts of rain, actually, in the other side of the world, in the Western Pacific. So let's take a look at that. We'll take a look at it first of all on our pressure sequence here. So if we zoom out and head over to the Western Pacific, where it is, of course, nightfall, and down, just clearing away from the Philippines. This area of low pressure here is actually typhoon Krathon.
That's right.
Have I pronounced that right? So that's sitting between the Philippines and Taiwan at the moment. Quite a powerful storm.
It is, again, this is around Category 4, so it's actually similar to the strength of Hurricane Helene at landfall. The critical thing with this is that it's very slow moving. It formed just off to the northeast of the Philippines, has drifted very, very slowly west over the last few days. So it's now sitting south of Taiwan. But the critical thing is where it goes next. We think the most likely scenario is that it does a very slow turn northwards and hits Taiwan. But it's possible that it might do something different. Let's
take a look at some of the scenarios. Well, actually, first of all, this is the current radar. So that's the actual radar where it is.
Showing the rainfall.
I have the storm quite clearly there.
And one thing we do find with typhoons that hit Taiwan is that they can produce absolutely enormous amounts of rainfall. And one of the reasons for that is on the east side of the island, you've got this very, very high ground. And if you've got the storm with if it's coming in from this direction, all the rainfall is being pushed into those mountains, and that causes an effect, what we call an orographic effect, which means that it rains out a huge amounts of moisture from the depth of the typhoon. You've got the storm,
you've got the depth of the typhoon, but you've got the
so it's not unusual with typhoons hitting Taiwan to get in the region of 500 to 1,000 millimetres.
And these are the projections from yesterday, it has to be said, from three main computer models, the Met Office model here, ECMWF, the European model here, and the American model here. And this is what they were suggesting yesterday. Quite tricky to pick out, but Taiwan is in here, so you can just about make it out there. And these white colours are anything above 500 millimetres of rain. And actually there's a 1,000 there picked out by the Met Office model, suggested we could see 1,000 millimetres of rain across that southeastern quarter of Taiwan, and the other models also highlighting huge amounts of rainfall possible. That was when the models were in agreement yesterday, but actually since then, overnight, they've kind of gone a bit awry in their projections.
I think the problem is that because it's moving so slowly, it's in a very slack steering current or steering flow. If a typhoon or a hurricane is moving very fast, that's because the upper level winds that are steering it are pushing it along, and it also, sometimes that gives us a fairly certain forecast of where the storm's going to go. Now, if you've got one like this, which is moving very, very slowly, and it's got competing factors all around it, kind of want to move it one way and the other, sometimes that can make the forecast much more tricky. And it seems as if that might be the case with this one, because although in the last couple of days we've thought that it was going to turn and go into Taiwan, there are some model predictions which are suggesting something different. And this is where what we call ensemble forecasting comes in, because what we do, we take a model and we kind of change the initial state of the model slightly, run it multiple times, and see whether all the tracks are the same or whether they actually diverge a lot, because there's a lot of uncertainty. And in this case, there's quite a bit of uncertainty. This map shows the latest forecast from the American global model, or their ensemble, and all these different tracks are different ensemble members, and you can see a lot of them
quite a few of them are still taking it across Taiwan,
but quite a few of them are actually taking it westwards towards Hong Kong and even further towards Hainan Island.
180-degree difference between some of those tracks. So, the different colours, I should say. Sorry, I couldn't get that all on there to show, but just because I wanted to show the different potential tracks, but the different colours represent the different central pressures, don't they? So the yellows are the deeper lows.
Yeah, so one thing we're fairly certain of is that it will gradually weaken over the next few days in terms of its wind strength. If it hits Taiwan, it will still produce a lot of rainfall, but because it's sitting in much the same place, often tropical cyclones do weaken if they're very slow moving, because they start to draw up cooler waters from underneath. But this just illustrates the uncertainty in the forecast, and that's one of the reasons why we often use ensembles. This one is the one from the European Centre, which doesn't have quite so many tracks going the other way, has more going towards Taiwan, but again shows there's quite a bit of uncertainty. So the current thinking is there's a higher likelihood of not that it'll hit Taiwan, but we have to bear in mind there's an option that it might go in the other direction.
One of the ways ensembles could be used is actually you can calculate the number of them that are hitting Taiwan, work out a percentage, can't you, from that?
Yes.
So say if 70% of the ensembles are going that way, then you could be 70% sure. But that's decreased, isn't it? That percentage compared to what we saw yesterday. So that's definitely one to watch, because the potential, as we've seen, for similar amounts of rainfall that we saw across Helene, a different storm in the fact that it's more slow moving, and whereas Helene was fast, it was easier to predict its actual path. This one is the opposite also, but also weakening as it does so because of the effects of the sea surface temperatures. Okay, one more storm before we go, Julian. Well, at least one more, because let's go back to the satellite picture. And actually, this is the remnants of Isaac. Well, we're not going to talk about Isaac today. Further south, there's Joyce, which is this messy system here as well. So there are a couple of decaying systems out in the Atlantic, but there is another one which is potentially very interesting indeed, and that's developing further south out in the southern Atlantic. If we fast forward to, is it this one here?
Yeah,
I think this is
it's Tropical Storm Kirk, as it is at the moment, and the computer models are suggesting it's going to become a very powerful hurricane in the central Atlantic, but thankfully we expect it, as it moves across the central Atlantic, to turn north. So this one is not going to go towards the Caribbean or the USA.
The Caribbean's just here.
So we don't expect any land impacts from this, but it will become very powerful, because in this area, as I've said earlier, the sea temperatures right across the Atlantic are very warm, and they're a couple of degrees warmer than average in this region. So even at higher latitudes, the sea temperatures are around 29 to 30 degrees Celsius. And this hurricane, as it will be, is going to tap into that and become very intense. And we do actually have the possibility of another storm behind it, which hasn't yet developed, but that's another one to watch. But I think the thing to emphasise with this is that we do expect it to turn northwards and not directly impact any of the areas, for example, that were affected by Helene.
But then it could interfere with, model predictions and a longer range across the Atlantic, and definitely something we need to keep a close eye on.
By the end of next week, so even 8, 9, 10 days from now, it'll still be up there. By then, it'll be an extratropical system.
Yes.
But what it'll be doing is still open to question, because it's so far away that there's a lot of different options as to what it could do and where it could go.
Something to complicate the longer range forecast for sure, and our longer range forecast, that'll be on YouTube tomorrow in our 10-day trend. I think it's Aidan recording that tomorrow, so interesting to see whether any of these tropical systems actually interfere with the UK weather in the longer term. So that is definitely something to keep an eye on. Talk about the sea surface temperature here, 29, 30 degrees, and it needs to be above. Whole point thing about tropical cyclones, the sea surface temperature needs to be above 26 degrees Celsius.
It's around 26, 27. It's not a hard and fast rule. It depends on other conditions. Sometimes you can get storms which will develop over lower sea temperatures than that. But typically, yes, 26, 27. So when you get up to 29, 30, you've got plenty of fuel for developing a strong hurricane, as we expect this one to be.
Brilliant. One to watch for sure. Julian, absolutely fascinating. Thank you so much for talking about the past, the present and the future storms over the next week or so. Thank you very much for joining me today.
You're welcome.
As always, a real treat to talk to Julian. I could talk to him all day. But I did promise you 2 special guests at the start of this week's deep dive. So, with a little bit of a fanfare, here comes our second guest. Welcome along, Honor.
Hello.
Honor, because you are joining the presenting team.
I am, that is right.
So this is very exciting. So keep your eyes peeled for Honor on our screens more often. Be doing the deep dive at some point in the future?
At some point I'll be doing a deep dive, yes, so stay tuned for that one.
Honor is in covering for Annie, who's obviously on maternity leave, so he'll be with us for at least a year, so plenty more of Honor to come. What are you looking forward to most?
Oh, I feel like I should say the deep dive, but I'm not sure.
It's quite intimidating with the screen, isn't it?
Yeah, I think once I get the hang of the screen, I'll be okay.
Yeah, you'll be fine. And you'll be doing the 10-day trend and all of those things. Not tomorrow, though. Aidan is doing the 10-day trend tomorrow, so make sure you catch that. That'll be available on Wednesday afternoon. Good way so you don't avoid the 10-day trend or any of our broadcasts is, of course, to hit subscribe and give us a like as well. But thank you very much for watching this week's Deep Dive. Keep your questions, keep your comments coming in, and we will see you again soon.